just wait a minute and see if anybody didn't give up. Did anybody hang in there? Yeah. Okay. Okay. We're fine. It's going to be... Okay. Dude, that's like what meat does to me. Yeah. Except it'll last like a week. I mean, it is so bad. Get it over with. You think you picked something up, or you think of something you ate?
I don't know.
Nobody else in your house is?
No.
It's not like you're going a lot of places.
Right.
There you go. I don't know. Mm-hmm.
Sometimes Ryan takes about 2 minutes to get on and stay on.
All right, so we got a couple, right? We have a few, okay. So the rest can catch up later. All right, so sorry for the delay, guys, but we'll get through it all. It's not going to be a long morning, much like yesterday, and so we're going to do some more work with our calculator, and hopefully the camera stays far away, because like this is no makeup. This is what no makeup looks like. So let me answer your question. I'm not sick, because that's usually the question I get. I usually get, are you feeling okay? I just don't have any makeup on, because apparently makeup isn't essential, and I can't get into Ulta. So anyway, it's going to be kind of raw here for a couple of days. Hopefully just days and not weeks. But I hope you guys are all doing well and feeling well. And so today's lesson is going to be 8.3b, and we're going to work on the next section. So what I want to do is just read through the section about doing inverses, and maybe just kind of help it make sense to you as you read through it, and just kind of decode it for you. So we are going to start on page 399. The next section is inverse trig functions on the calculator. Okay, so let's just kind of read through this, and then I'll just kind of tackle it as we go along. The previous example found the trig function values when we were given an angle. So yesterday we were given an angle, and from that angle we found the trig functions, okay? So what we're going to do with these inverse statements is we will be given the trig function, and we're going to find the angle. So that's just, it's basically an extra push on your calculator is all that is. So I'll stick to the script here. Some problems require the angle when given the trig function values. These statements are inverse statements. The input and the output have been changed. In order to find the angle, and this is in bold, inverse trigonometric functions are used because they take the output from the trig function and provide the input, okay? So now we're on that second paragraph. Inverse trig functions can be written one of two ways. The first is similar to an inverse notation, and so that's probably what you will recognize it as looking like, because we have done some inverse functions before. So the inverse of sine, so this is in that paragraph, can be written as that, okay? So this is a trig function. This would be the inverse. And then likewise, cosine would look like this, and tangent. So these are the inverses. Okay, what this does not mean, because what this looks like, it looks like an exponent of -1, which could make it appear to be a reciprocal. Like if I did this, if we just looked at this, it would look like this too has an exponent of -1, and so this would be 1/2, okay? It would just be the reciprocal of this, okay? But that is not what this means, okay? So don't confuse the two. So that's what that second paragraph is explaining. So the second notation, the second way to denote an inverse function is to put arc in front of it, okay? Arc, well, they just do an A, I think. Sometimes it's written out, sometimes it's not. Okay, that's also another way to write inverse functions. Okay, so the next paragraph, these inverse trig functions can be used to solve for angle measurements, and that's what I really want you to focus on. This is what we use when we're looking for the measurement of the angle, okay? When you're looking for a degree, how many degrees is the angle? That's when you use the inverse functions, okay? In the same way that a square root function, so that whole paragraph, all it's doing is saying this undoes this in the same way that a square root undoes a square, okay? Like if you have x squared and you're trying to solve for x, the inverse of that would be a root, a square root, okay? These undo each other, okay? These undo these, okay? That's all, that's just summarizing all what these paragraphs are saying, okay? So it could seem really complicated if you're just reading the text, but hopefully this makes sense, okay? So, so let's talk about this. Given this, sine theta equals 1. So if I was trying to solve for this, theta always represents the angle that we're looking for, okay? So if I'm trying to find the measurement of this angle, I need to undo this, okay? Well, it's not as simple as just dividing by sine, okay? Because these are not being multiplied together, right? So to isolate theta right here, to get this by itself, we would do the inverse. This undoes this, okay? If that's a word, undoes, okay? And so what you do to one side, though, you would have to do the other. So let me actually pull that down. Okay, so if I'm looking for this angle measurement, I'm given, this is my trig function, and I need to undo sine. I do the inverse, and I do it to both sides, okay? So this just takes all of that away, all right? This undoes this, leaving me with just theta, okay? Now, this is the inverse of sine of 1. Okay, so that's what we're going to work with on our calculators today, okay? So I just want to, you don't have to go through all of this to solve these problems, so let me just say that. But I just really wanted to explain what you're seeing on the paper because it needs to make sense to you, okay? Like why we're doing what we're doing. You're not going to have to do all of this on paper, but you certainly need to understand what it is that we're doing, okay? So, calculators. So hopefully they're still in degree mode. Hopefully up at the top of your display window right there, you still have that D, okay? In this paragraph, it says that you can check it. So yesterday we did the sine of 90, I think, and it was supposed to equal a 1. Okay. So if it still does that, then it's correct. Okay, so let's go ahead and finish this. All right. So on your calculator, so you see where your sine, your cosine, and your tangents are. So if you shift those buttons, you have your inverses. So right above sine, on my calculator, it's in yellow. It has this. Okay, so this is my arc sine, my inverse of sine. And then you shift cosine and you shift tangent. Okay, so if we were to, let's try to find this angle right here. All right, so basically we're asking ourselves, the sine of what angle equals 1? Okay, I need that angle. I need to know the degree of that angle, okay? So all you have to do is, on your calculator, do shift, sine, and then that number 1 right there, and hit equals. That's 90 degrees, all right? So I know that my angle is 90 degrees. And let me remind you guys the importance of this little guy right here, right? For the most part, you guys are doing a good job of using your degree symbol. Don't stop. I'm still seeing, you slip up every once in a while, but just be very consistent in using that degree symbol, okay? So let's just walk through these examples. In example 8.3b, let me get rid of some of this. Okay, so so the part A of example 8.3b has sine theta 1/2 equals 1/2. Okay, so I undo this sine, I isolate theta by doing the inverse. And what I do to this side, I do to this side. Okay, this undoes that. isolating that angle. And so then you just punch that into your calculator. So I would hit shift, sign, and then I punch in that fraction 1/2. Okay, if you want to, you can move your cursor out of the denominator. You can move it over, close your parentheses if you want to, but I don't think that you have to. All right, so this is 30 degrees. So what this means is the sine of a 30-degree angle is 1/2. That's what you did yesterday, okay? We're just having to work the other way. We are given the trig function, and we're having to find the measurement of the angle, okay? So turn the page. We have cosine A equals 2/3. So again, A is representing that unknown angle that I'm looking for, so I got to do the inverse, all right? So I'm going to do the inverse of cosine. So that eliminates that. And then I got to punch that into my calculator, right? So shift cosine, and then I just punch in 2/3. I hit equals. All right, so this is a decimal. So let's talk about rounding. So this spit out 48.1896851. Okay, now what do? The directions say to round 3 decimal places if necessary. So let's just review rounding, right? So 3 decimal places means that I'm allowed 3 numbers behind the decimal. 1, 2, 3. All right, so I got to decide what's going to happen to the 9. Is it going to stay a 9, or is it going to be rounded up? So I look behind. That 6, since it's 5 or more, is going to round that 9 up. So that 9 is going to go up to a 0, and this 8 is going to turn into a 9, because 89 basically rounds to 90. So I'm missing a marker. Okay. So there's a little rounding, except I rounded, so I should do that. And I should have a degree. So it's about 48.190. So it's really important that you have the 0. Okay, I have to have 3 numbers behind the decimal, even if it's a 0, all right? So 9 just rounds up to a 10, and so that means I got to move over to the next guy, round him up, turn that 9 into a 0. So hopefully you guys remember all that rounding stuff. I don't know, you probably haven't done it since elementary school, so that's why I'm just reviewing this, okay? So y'all let me know if you have any questions about that one right there, and then I'll move on to the next one. So the last one is tangent B equals 5. Okay, so I'm looking for this angle right here, angle that we've named angle B. So I've got to do the inverse. So that gets rid of that. Here we have angle B. So now it's time to work your calculator. So I shift tangent, and then I punch in 5 equals, so we've got 78.5 0.69006753, and I have to round 3 decimal places, so that's 1, 2, 3. So this is the guy. I'm trying to decide his fate, and behind him is a 0, so he stays 0. So that is approximately 78.690 degrees. Okay, again, I have to have 3 numbers behind the decimal. Even if that last one is a 0, it's still important that it's there. Remember, if you round, you don't put an equal sign. You put an approximate sign because it is a rounded number. And don't forget your degree symbol. Okay, so all of that, here's the takeaway of all of this. This is what I want you to always remember. If you are looking for the measurement of an angle, like I need to know how many degrees this angle is, just shift it, okay? You shift sine, shift cosine, shift tangent in order to find the measurement in degrees of angle, okay? That's what I really want to stick, okay? So, any questions?
Ryan says that the 4th decimal behind the decimal.
The 4th number.
Yeah, is 6 or higher, do you round up?
Yes. If it's 5 or higher, you round up. Even a 5 makes that 3rd one round up. 6 is not the border limit. It's 5. Okay? 5 or higher, you round up. 4 or lower stays the same. Okay? It doesn't change. Never round down, because I've actually seen that before. Okay? It doesn't round down. It either stays the same or it goes up 1. Okay? All right, was that it? Is that all we got? Yeah? And I might have even answered that question by the time he got that typed in there. Okay, so this is your assignment for today. You'll do the next section, problems, and I think that's it. I don't have anything else. We're certainly not gonna, we'll finish up the next section tomorrow, and then we'll be done with 8.3. So we have like 2 examples, I think, to go over. Tomorrow, we'll actually start working with some triangles and find some angle measurements, okay? So if you have any problems, reach out on Parent Square. I'll be happy to help. All right, y'all have a good day.